So 2012 relative velocity at noon, ship A is 50 kilometers north of ship B. Let's do it. Diagram A is 50 kilometers north of B. Ship A is traveling southwest. It's going in this direction, so that's 45. At 24 root 2 kilometers an hour. 24 root 2. Ship B is traveling due west. Ship B is going in this direction at a speed of 17 kilometers an hour for ship B. And 24 root 2 for ship A. A and B can exchange signals when they are no more than 20 kilometers apart. This is for part B. Part A, find the magnitude and direction of the velocity of B relative to A. So we need the velocity of B, easy enough. Velocity of B is in the minus I direction, so minus 17 in the I direction, and it's not moving in the J direction. The velocity of A, it's in a minus direction down here, so it's going to be minus 24 root 2 by the well, is it because of the angle? The I vector is actually opposite, isn't it, to 45 here? Just, we don't need to be too careful in this one, but always be aware of where the vector is coming from. It's sine 45 is where it's coming from here in the I direction. Minus 24 root 2. The J is adjacent to the 45, so it's cos 45 in the J direction. Sine 45 and cos 45 are 1 over root 2, so the root 2's are going to cancel, so we're going to get minus 24 in the I direction, minus 24 in the J direction for the velocity of A. We want the velocity of B relative to A. Velocity of B minus the velocity of A, which in this case is going to be minus 17 minus minus 24, so that's going to give plus 24. So that's going to be 7i, and we're going to have 0i minus minus 24 plus 24j. That's the velocity of B relative to A. We're asked for the magnitude and direction of it. So the magnitude, can you recognize the 7425? The square root. You're always going to write this out anyway, just to show the examiner what you're doing. 7 squared plus 24 squared is going to give 25 as the answer. 49 of 576 or 625. Square root of 625 is 25, and the direction theta is equal to the inverse tan of 24 over 7, which is going to give, that's going to give 79 or 73.7 degrees. 73.74. 74 will take 74 degrees. Okay, that's positive. So let's just have a look at that direction there. Positive. It's going in this direction here. 73.74 north of east, or NOE. Okay, so where are we at now? A and B can exchange signals when they are not more than 20 kilometers apart. So let's do a diagram for that. So if we have the velocity of A relative to B going up in this direction. We have A here north of B, B at the origin, and we have this is the velocity of B relative to A, actually A, not A relative to B, B relative to A, and we have our 73.74 in here. Now the shortest distance, just change colors here, the shortest distance looks like approximately here. Can we get that straight away? We could get that straight away. Let's just get that straight away. We have in here, we have the angle 90 minus 73.74, which is 16.26. And we have x, and we have, what was the distance between them? 50. 50 was this distance here. So we can say that we want opposite, and there's my right angle. We have hypotenuse, so we can say that the sine of 16.26 is equal to x over 50. 50 sine 16.26 degrees is equal to x. So we can get the shortest distance. I'm not sure we even need it, but let's get it anyway. The shortest distance is 13.999, so I'm definitely going to round that to 14. I think we're dealing in kilometers here, kilometers. So we have x now. Let me just rub out this line here and put my 14 in. So we have 14 here. And where is they can exchange signals while they're a certain distance apart. Let's say that it's this distance in red here. And we know that over the other side, symmetry is going to tell us that that distance exists there as well. So they're going to be able to exchange signals in this block in here between these two red arrows. So what information do we have that will enable us to get this distance here? So we're actually given that distance, that's 20 kilometers. And when can they begin? Okay, so when can they begin? So we're looking for this point here. I'll do it in a big red dot. We're looking for this point. When can they begin to exchange signals? So if I take that triangle that has the 14 on it, 14, my right angle, and my 20, I can get my, I'll call it x again. X is equal to the square root of 20 squared minus 14 squared. 14.28 is that distance there. So we're doing a new diagram here. So I have my A and my B. So new diagram. So what have we done? We've used this triangle here to get this distance here to be 14.28. So if we could get the distance from B to this first red dot along this green line that I'm coloring in, we could get how far he needs to travel before getting within distance. And we have this distance of 50. So I can use my right angle triangle with 50, 14. We call this one y this time, so y is equal to the square root 50 squared minus 14 squared, and that's equal to, which gives me an even 48. So we have 48. If we say 48, take away that 14.28, it'll give us the first section, which is going to be 33.72 kilometers for this bit in here. So what speed is B traveling at? It has to travel a distance of 33.72 kilometers. So at what time will they begin to exchange signals? There was something about noon in the question. Noon. And ship B is traveling at noon. Ship A is 50. Ship A is traveling. Ship B is traveling due west at 17 kilometers an hour. So 17 kilometers an hour. 33.72 divided by 17 is just under 2. 1.9835 hours, which is 1 hour and 59 minutes. We could probably round that off to 2 hours. I'm not sure what we're asked here. Let's have a look in the question. Does it ask us to round? Well, we can say here 1 hour 59 minutes after noon is 13 hours 59 minutes is when they can begin to exchange signals. And I just realized I've taken the wrong speed there. I haven't taken the original speed. I need to take relative. We're doing relative here. Speed is 25. 33.72 divided by 25 is going to give 1.35. And 0.35 by 60 is 21 minutes. So 1 hour 21 afternoon is 13:21. Just be careful with the speed, a mistake that you don't want to repeat. And then there's the last part. How long can they continue to exchange signals? Okay, so how long are they within range here for our second diagram? Do we have a value yet for that? Okay, so we worked out x So we have this range here. We have x. Yeah, we have x to be 14.28. So that's 14.28 by 2. 28.56 kilometers there in range. The speed is relatively 25 kilometers an hour. So if we divide 25.56 by 25, and 28.56 divided by 25 is 1.1424. 1.1424. That just looks like a 5 actually, it's an 8. And 0.1424 by 60 is going to give 1 hour and 9 minutes that these guys can stay in contact.